sketching our polynomials. We did a little bit of this earlier, obviously, in our graphing topics. But so some of this we have talked about before. But let's just recap it, seeing we're talking about polynomials now. So, when we're drawing a polynomial, y-intercept is always the constant number. It's the same with a straight line. It's the same with a quadratic. It's true for any polynomial. So for this one here, and remember, if it is in factorised form, you don't have to expand the whole thing out, because we know the constant times the constant will always give us the constant number. So for this one, what do we got? 1 times minus 1 cubed, that's minus 1, isn't it? Very good. Times 2 squared, minus 4. Minus 4. So we can plot that one in. Now, the x-intercepts are the roots, which is handy because this one's already factorised. So we know they'll be at -1, 1, and -2. Okay, now, where does the polynomial actually start and finish? The leading term of a polynomial will always dominate. So really you just need to look at the leading term and think to yourself, well, if I was to draw this, where would I start, where would I finish? And then our polynomial will be exactly the same. So again, don't need to expand the whole thing out because we just want the leading term. X times x cubed times x squared. 6 am I up to? X to the 6. So we know that'd have some sort of U shape. So we'd start up the top here somewhere and finish over there. Now the actual roots themselves behave like the factors. So whatever the power is, then we know that at that x-intercept, it'll behave like that. So in our one, at -1, it's to the power of 1. So it'll come through like a straight line. At +1, it's to the power of 3. So it'll come through like a cubic. And at -2, it's to the power of 2. So it'll just touch it like a parabola. And we would end up with something like that. So you can see at -1, it's going through like a straight line. Now that we've done a bit of calculus, we could identify this point a little bit clearer, because the one thing we notice with our turning points is the tangent of that point is 0. So if we wanted to, we could investigate further and find exactly where that particular point is. And we will do that later. Okay, now, if it can be perfectly factorised, then we know what's happening is we've just got that basic curve and we've shifted it so many units to the left or so many units to the right. Okay, let's try this one. X minus 1 to the 4, x plus 1 cubed, x plus 2 squared, x minus 2. All right, so this is what the graph looks like. But again, let's go over all those features. We said that the y-intercept is the constant. So in this case, we'd have -1 to the power of 4, which is 1. 1 cubed, that's also 1, so we're still at 1. 2 squared, we're now at 4. Times by -2, so it's cutting here at -8. The x-intercepts. At 1, it looks like a quartic. So notice how it's not a parabola, but it's a bit flatter at the base, steeper at the sides. Remember, as that number gets bigger and bigger, the flatter it gets at the base, the steeper at the sides. -1, we've got a cubic. At -2, that one's going to look like a parabola, and then it just cuts at +2. That'll do us.